Next, we move on to problem number 2, and this time around, we are going to be estimating the area, but we are going to be using the right endpoint. Now, many things transfer from problem number 1. So to begin with, we are going to be using 4 subintervals again, or 4 rectangles, and we still have the same subinterval. So our delta x this time around, even though we compute it the same way, and I'm not going to demonstrate that because it shows it in the previous video, it is going to be equal to 0.5. So now I'm going to be zooming in to my interval that I'm going to sketch, and you might recall from the previous example that these were my points on the interval, and I added additional points so that all the points that we use are 0.5 units apart from each other. And then, of course, I had my 4 rectangles. Now, these are not what the rectangles would look like necessarily, but I'm just drawing them here, especially of different sizes, so that it looks clear that they're all different sizes. They're not drawn to accuracy for this case. What I've also done is I labeled my rectangles as R1, R2, R3, and R4, and the reason being that I'm using those right endpoints to determine their height, unlike the previous example. So what we're going to do then is we're going to write down the height of the rectangle R1. So height of R1, this is the function evaluated at 1.5, and just to point out, this is the same function as before. The height of R2, this is the function evaluated at 2. The height for R3 is the function evaluated at 2.5, and the height for R4 is the function evaluated at 3. So if I plug in all of these numerical values into my function and use my calculator, well, the first one we actually used in problem number 1. That's the same height, except it applies to a different rectangle. In this case, f of 2 is also from the previous example in problem number 1. For this one, we will have 0.181818, and for the last one, that's a different one. We're going to get this as the height. And as before, the area, the sum of the areas of all those rectangles, I'm going to write it a little bit differently. That's going to be delta x, that's our base, times the height, which is f at 1.5, plus delta x times f at 2, plus delta x times f of 2.5, plus delta x times f of 3. So next, I'm going to use the calculator, and I'm going to replace all of my numerical values. So delta x, just as a reminder, was 0.5. So this quantity here that's getting highlighted in red is what's going to be replaced into those delta x's. And these quantities, that are getting highlighted in green are going to be replaced into those quantities that you see right there highlighted in green. So when I make all those substitutions into the calculator, in fact, I could factor out a delta x from everything. So let me do that. So if I factor out a delta x, I will be left with an f of 1.5 plus f of 2 plus f of 2.5 and lastly plus f of 3. And these values, when we compute them, will give us 0.5, and the sum of those four values is going to give us, let's see, we were going to have f of 1.5 plus f of 2 plus f of 2.5 plus f of 3. So this is going to give us 0.5 times 0.770707, and multiplying those two together will yield the following value. That's going to yield, let me make some space here, 0.385354, and this over here is our approximation, so is our approximate area.